So the second thing that we're going to do for this part, 4.1a, is that we're going to simplify if it's a division problem and we've got the radicals. So the main idea here is if you have a square root of 3/4, we can take the square root of the top and the square root of the bottom separate. The square root of 3 we can't do, so it stays square root of 3, but the square root of 4 is 2. And so this would be my answer. Or if it's got letters, if it's square root of a over b, then it's the square root of a over the square root of b. And the only thing we have to remember is that we want to make sure that a is positive because we can't take the square root of a negative. And we want to make sure b is not 0 because we don't want 0 in the denominator. So when I look at it, the examples that go with it, the very first thing we're going to do is we're going to break it down. So we're going to go square root of 15 over square root of 64. And again, as we look at it, we can go, okay, this is 3 times 5, and this is 8 times 8. 3 times 5 does not have anything that can break down, so we can't do anything up top. So this will stay square root of 15. Now, if I look at 8, I do have a pair right now, so I can put an 8 on the bottom and be done. But let's pretend we didn't break it down that way. So if we didn't remember or didn't notice that 64 is 8 times 8 and we start with something different, my final answer is still going to be square root of 15 over square root of 8. But you might have a longer process to go through. So if I say this is 2 and 32, and then I'm like, oh, this is 4 times 8, this is 2 times 2, this is 2 times 4, this is 2 times 2. And then remember, if we cross off all the ones that we broke down, then what we're left with are all of these 2's. And so as we look at it, we've got, again, still square root of 15 on top because we couldn't do anything. So there was no pairs, so it stays 15. But on the bottom, I've got a pair of 2's. I have a pair of 2's, and I have a pair of 2's. And so 2 times 2 times 2 is 8. And so we still get 8 on the bottom. Probably write that a little bit different. So this would still be square root of 15, and this would still be 8. Whether I notice that the square root of 64 is a perfect square or not. Same thing with the next one. So I'm going to do square root of the top, which is 81, square root of the bottom, which is x squared. And then we're just going to break it down. So square root of 81, same idea. If I notice that it's 9 times 9, great. If I don't, then you're going to have a longer process, but you'll still get the same answer. I have a pair of nines, so that goes on top. And you have a pair of x's on the bottom, so that stays on the bottom. So this is my answer. So we can extend both of those rules to when we have a cubed root. So the same idea is going to happen here. So if you have a cubed root of 128, so before I talked about how if there was nothing there was really a 2, so I looked for groups of 2. Well, now we're going to look for groups of 3. So when I look at 128, I'm still breaking it down the same way. I know that it's even, so 2 will go into it. So 12 divided by 2 is 6. 8 divided by 2 is 4. And I'm going to break that down. So we just did that up above. 64 is the same thing as 8 times 8. We can break out 8 to be 2 times 4, and then 4 to be 2 times 2. And then 8 is 2 times 4, and 4 is going to break down to be 2 times 2. And again, once I break it down, it's gone. And so now when I look for pairs, I'm looking for 3 because there's a 3 on the shelf. So I've got 3 2's here, so we write it down. We have 3 2's here, so we write it down. And then we have this little 2 that wasn't in a group of 3's, so it stays under the root that has a 3 on the shelf. And so now we multiply. 2 times 2 is 4, and we get 4 cubed root of 2. If I was doing B, it's the same thing. I still am looking that I've got a group, or I need a group of 3. So I look at negative 125. And again, if I do it to the side or if I do it down, it doesn't matter. It ends in 5, so I know 5 goes into it. So 5 into 125 is 25. And then 25 breaks down to be 5 times 5. Now we do have an issue right here with this negative sign. We talked about how if it was the square root or an even root of a number, then it was undefined or not possible. In this case, we're okay because it's a negative. And so in order to get a negative with 3 numbers, all of them could be negatives. Or we can make that -1 be a -1 and break it down, but it gives us the same value. And then x to the 7th gives us 7 x's. So I'm just going to write it like that. And then again, we're still looking for groups of 3 because that's what's sitting right here on the shelf. We don't need the 25 because we broke it down. So we've got 3 -5s. We have 3 x's. And we have 3 x's. And so what's left over is this little x here. So we've got cubed root of x. So when we simplify, we get -5 x to the 2nd cubed root of x. And the little 3 that sits on the shelf, the index, it matters. We need to make sure we have it there. When we look at division, it's the same idea. We're still going to break it down into 2 pieces. So we're going to go cubed root of y, which is the top, and cubed root of 216, which is the bottom. And when we look at the top, because this is a y and this is the cubed root, we can't do anything with it. So it's going to stay cubed root of y. On the bottom, though, we're going to try to break that down. So we're trying to figure out something that goes into 216. We probably don't know we probably don't have that off the top of our head. So we could start with 2. So if I go 216 divided by 2, and I choose 2 because I know that it's even. If you want to just do guess and check, you can do that as well. That's just a little bit more work. But 2 times 108. And then if we look at 108 and we remember that that's 9 times 12, great. If not, you can do it, divide it by 2 again. It's kind of up to you, whatever's easiest. If that's not an easy one for you, then you could just do the 2 and 54. And then you could look at your chart if you needed to on 54 and see that it's 6 and 9. And 6 breaks down to be 2 and 3, and 9 breaks down to be 3 and 3. And again, if we have a tree coming off of it, we just cross it out. And then we look for pairs. So as we look at pairs, we have, or not pairs, we're looking for 3 of a kind. So we have 3 2s. So we write it down. And then you have 3 3s. So we write it down. And so then our answer ends up being the cubed root of y over 2 times 3, which is 6. And so we always want to break that down. So when I do cubed root of this one, I'm going to go cubed root of the top over cubed root of the bottom. And again, we simplify both if we can. So top is I look at 8. 8's the same thing as 2 times 4. 4 breaks down to be 2 times 2. And then there's 4 x's. On the 27 on the bottom, that's going to be 3 times 9. And 9 breaks down to be 3 times 3. And we've got 3 y's. And again, the 9 we broke down, so we don't need it anymore. And because we have the 3 that sits on the shelf for both of them, I need 3 of a kind in order to do something. So notice on the top, I have 3 2s, so it's going to stay on the top. And I have 3 x's, so an x is going to come out. And there's 1 x left over. So this is the cubed root of x left over on the top. And then on the bottom, we've got 3 3's, and 3 y's. And then notice there's nothing left, and so this is my answer. I'm done with 2x cubed root of x over 3y. And then as we look at our monitoring progress, you may want to just pause your video for a minute. Look to see if you can do these 3, and then come back and check your answers. So number 1, you should have got square root of 23 over 3. Number 2, negative square root of 17 over 10. Number 3, 6 over z. And 4, you should have got 2x over 8 which you can simplify to be x over 4. If you need help on those, make sure you ask. All right, I'm just going over the answers for those 4, because most of those you can take the square root of the numbers. So when you look at 5, remember that the idea of there being a 3 makes it so you need to break it down. So always break it down if you can. So this is 2 and 3. Oops, it's not a 2. This is 2 times 3, and 9 is 3 times 3. Common mistake when you simplify is that when you do that 6, that you just do that the mistake I just made, which is do 3 plus 3 instead of 2 times 3. So when we're breaking it down, make sure you're doing what times what gets you the number, not what plus what. So this goes away, and then because of the 3, you're looking for a group of 3. So I have 3 3s, so that comes out, and the 3 stays on the shelf, and the 2 is going to go underneath. And then when I look at the 3 here, same thing, I'm looking for 3 of a kind. So when I look at 16, that's 4 times 4, 2 times 2. These go away. We have 4 x's. And again, we're looking for 3 of a kind. So I have 3 2's. We write it down. I have 3 x's. I write it down. And what's left over is a 2 and an x. So I have cubed root of 2x. So that's my answer. And normally, like if you're putting it in the computer, we don't put the dot in between. We just write it like that. Remember that in order to put the cubed root down on your computer, you're going to have to change the keyboard from basic to algebraic, or the X keyboard. For 7, remember we break this down into 2 values, or 2, like the top and the bottom. So you're going to do cubed root of a and cubed root of negative 27. A, there's only 1, so it's going to stay there. So that's going to stay the cubed root of a. And the 27 is the one that you're going to want to break down. So this is 3 times 9, 3 times 3. Because it's a negative here and this is an odd, all of them can be negatives. So when we look for 3 of a kind, for the bottom, you've got 3 negative 3's, and so that's going to go to the bottom. And there's nothing left over, so we're done. When you look at number 8, we're going to do the cubed root of 25 c to the 7th d to the 3rd all over the cubed root of 64. And the same thing is going to apply here. We're going to simplify the top and then simplify the bottom. So when I look at the top, 25 breaks down to be 5 times 5, and then we have 7 c's and we have 3 d's. And then on the bottom, as we look at 64, we're going to do 8 times 8. So 2 times 4. 4 is going to break down to 2 times 2. And we're going to look for our pairs. I think I'm going to write this a little bit different. Well, let's see how we can do that. Let me move that down, going down instead of sideways, so we have more room. So this, again, was 8 times 8. We broke it down to be 2 times 4, 2 times 4. 4s we broke down to be 2 times 2. And then remember, if it has a tree off of it, we just can cross it off. And now we're looking for 3 of a kind. So we've got 3 2's, so we write it down. And we have 3 2's, so we write it down. And so when I'm looking for 3 of a kind up on the numerator top or part or the top, I've got 3 c's here and 3 c's here and 3 d's. So 3 c's brings a c out, another group of 3 c's brings another c out, and another group of 3 d's brings a d out. And then what's left over is a c and both of those 5's. Because I don't have 3 of a kind, they all have to stay underneath the radical sign. And on the bottom, 2 times 2 gives us 4. So when we simplify, we get c squared, because there's 2 of them, d, cubed root of 25c all over 4. And this would be our answer. So that one's a little more long and drawn out. So we are going to stop the video for this one, and then we'll talk about rationalizing the denominator in the next video.